Okay, here we go. Welcome to Algebra, Chapter 1, Section 1. What I need you to do is I need you to read those 2 pages that introduce Section 1 of Chapter 1. In it, it's going to give you some key terms, algebraic expression, variables, term, factors, product, power, exponent, base. Those are all very important. It's not so important that you have to know them by heart right from the start, but these are going to be expressions that you will hear, terms that you will use over and over again throughout algebra. What I would like you to pay particular attention to, though, is anytime you see a box that looks like this, example 1. Because when the work starts, out to the side, it's going to say example 1, and you'll know that in order to do them correctly, you will follow this example right here. For example, write a verbal expression for each algebraic expression. So now when we get over to where the work begins, look here. Write a verbal expression for each algebraic expression. Example 1. If you're confused about what to do, you go back to example 1 and you look and you see here is the task that was to be performed and here is the answer. On the very next page at the top, anytime the book says key concept, that's also going to be very important. If we look through this box right here, it has these real simple operators over here on the left-hand side. And on the right-hand side, verbal phrases. So when we're reading and we come across the phrase more than, we know it means add. Increase by means add. Less than means subtract, and so on. That also will be important. Then, we always get to do it the other way around. Example 1 said, write it out verbally. Example 2 says, write it out algebraically. Write an algebraic expression for each of the verbal expressions. And looky here at the next set of exercises. Write an algebraic expression for each verbal expression. Example 2. That's the way this book works from beginning to end. If you're confused, you look over to the side, see what example gives you help for the series of exercises that you're working on. Go look at it. And the work that you're to do is going to be very much like the work they do in the example. Here's what I'm going to do. First, I must tell you about some of these verbal phrases. There are 2 in particular that have very special meanings. The first one is the phrase more than. More than. More than means to us add at the end. Now let me give you a practical example of this. Suppose I had $20. Okay, I've got $20. But somebody said that you, and I'm just going to call you, suppose you had $5 more than me. Well, that would mean that you have 20 plus 5, $25. More than. Add at the end. You had more than 5 more than 20. Well, addition really isn't that stringent. You would get the same answer if you did 5 plus 20 equals 25. And you might be asking, Why is he so crazy about that? If you get the same answer, what difference does it make? Well, it's a matter of discipline, and it's really going to help if you can get that in your mind. More than means add at the end for when you get to the phrase less than. Less than. Less than, very much like more than, it means subtract at the end. Now, less than is stricter than more than. With more than, yes, it could be done either way. Get the same answer. Less than, not so. So if I have $20 and somebody said that you have $5 less than my $20. Well, that would mean $5 less than would mean subtract at the end. That would mean that you have $15. And that makes sense. If you have $5 less than me and I have $20, then you have $15. If we tried to do it the other way without regard to subtracting at the end, and we tried to do it like this, we would absolutely not get the same answer. In fact, we would be off by $30. Instead of getting $15 as a result, we would get negative $15. That's a difference of $30 from where you're supposed to be. I just want to point that out. More than means you should add at the end. Less than, subtract at the end. This is the more strict of the two. Okay, so what I want to do now is I just want to work through some of these problems. In the back of the book is the answers to all the odd number problems. So I'm just going to work some of the odd problems to give you an example of what your work should look like. Let me flip the page here. Okay. Number 1. 2m. When you're doing algebra and you're given an exercise to do, you always start by writing down what the exercise is. 2m. The task is write a verbal expression for each algebraic expression. You're going to write this out using words just the way that you would read it. What is going on? Here's a 2 and an m. They're butted right up next to each other. That means they're being multiplied. There are several different ways that I can write this out. I'm going to look over here in these key concepts to give me an idea of some of the words that I can use. Product of, multiplied by, times, or of. I think I'm going to use the times because if I write 2 times m, that's pretty simple, and that is exactly what's going on here. So 2 times m, and that's it. Let's look at number 3. A squared minus 18b. So here's number 3. A squared minus 18b. Now look at how I'm doing my work here. I left a blank line between the first answer and where I begin the second answer. Again, I wrote out the exercise. So what do I do here? A to the second power. How am I going to write that? It doesn't have exponents in this box here under key concept. So let me look back at example 1 and see what they did. And here's one down here at the bottom. Very much like the one that I have to do. And they do 5 times z to the second power. Okay. 5 times, because the 5 and the z are butted up together, z to the second power. Okay, so what can I write? I don't have a coefficient in front of the a butted up to it, so it's just going to be a to the second power. And what comes next? I've taken care of this. Minus (18) times b. Now here I wrote the word 2. Here I just used the number 18. I really don't care if you write the numbers out or if you just use the literal numbers. That's up to you, as long as you get this pattern correct. A to the second power minus 18 times b. I could have also said the product of 18 and b less than a to the second power. My point in writing this is to use this phrase less than, but also to point out that there are many different ways to verbally write the same algebraic expression. Number 5. This time, write an algebraic expression for each variable expression. Number 5. 6 less a number t. All right? 6 less a number t. Less. That's slightly different than less than. In this case, we would be very literal in how we did it. It's 6 less. It's from the 6 that's being taken away this time, and we're taking away this number represented by t. There we go. 6 less a number t. Number 7, 1 minus the quotient of r and 7. 1 minus the quotient of r and 7. 1 minus, that's 1, take away. 1 minus, what are we going to subtract from the 1? It's the quotient, and quotient means division. From 1, we're going to subtract the division of r and 7. Whatever comes first in this phrase goes on top. Whatever comes second goes on bottom. R and 7. We could also write this as 1 minus, and then R divided by 7. Both of those have equivalent meanings. Now, I'm just going to keep going here with some of the odd numbers. Once we get down to number 11 here, it begins again. Write a verbal expression for each algebraic expression. Example 1. It's going to be very much like problems 1, 2, and 3. Exactly the same thing. It's just more practice. Let me pick one out here that seems more involved, like number 15. We have 3x to the second power. Just like we're reading a book or a sentence, we start at the left and we read to the right. We start with the 3 first and we're going to go to the right. It's 3 and then an X. And what's happening with the 3 and the X is they're being multiplied. Now we can call that a product. When you have 2 or more things being multiplied together, the answer is the product. If you say the product of, then you write down what the things are that you're multiplying together. We'll just make it a little simpler than that, and we'll use the word times again. So it's 3 times. The 3 is being multiplied to the X, and the X is being raised to the power of 2. There we go. Lastly, let's see, beginning with number 19, it's just write an algebraic expression for each verbal expression. Write an algebraic expression for each verbal expression. Example 2. Example 2. It's more of the same of what you did there. All right, I'll pick one that seems the most involved. Number 25. 3 times a number plus 16. Okay. They don't tell me what the number is that I'm multiplying. They don't give me a letter for it. In those cases, when they just say a number, then you just pick a letter, normally N, or you can also use X. Number 25. 3 times a number plus 16. 3 times a number. Well, this was 3 times a number. So 3. Instead of using X, I'm going to use N for numbers. So N, 3 times a number, plus, well, I know that means the plus sign, 16. There we are. It's done. But this is what your work is going to look like. And what I would like you to do, your assignment, is 2 through 30, the evens. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. That's your assignment. This is how I want your paper to look, with your name right here at the top right-hand corner. Your name. Don't write your name. Write the name that your mom and dad call you, your first name and your last name. And that's it.